In this video, we're going to discuss how you can solve systems of equations algebraically using substitution. System of equation is when we have two equations of either two lines or any other two functions, and we want to find where do those two lines or those two functions intersect. That point where the two lines, two functions intersect is a solution to both of the equations. Let's say we have the system of equations 3y is equal to 6x plus 2, and we have x is equal to 2 plus y. We want to solve this algebraically. You could solve it graphically on your calculator, you could solve it graphically by hand. We want to solve it algebraically. Using the method of substitution, we plug in one variable into the other equation. So let's say we have, this is a pretty easy question because we have one of the equations already solved for a variable. We have this equation solved for x. Since we know that x is equal to 2 plus y, we could plug in, for this x over here, we could plug in 2 plus y. By doing that, we rewrite our equations that it only has one variable. So if we would do that, we would have 3y is equal to 6 times 2 plus y, because we know that x is 2 plus y, plus 2. Now we only have one variable in the equation, and it's very easy to solve this equation for y. So let's do that. 3y is equal to 6 times 2 is 12, 6 times y is 6y, plus 2. And now we're going to combine like terms, so minus 6y minus 6y. Negative 3y is equal to 12 plus 2 is 14. Divide by negative 3 and divide by negative 3. Y is equal to negative 14 over 3. And that would be what y is. That would be the y coordinate of the intersection of these two lines. But we want to know what is the x coordinate also. So to do that, we are going to plug in what we just got for y into either one of the equations to solve for x. So let's plug into the second equation. X is equal to 2 plus y. And now we have a value for y. So x is equal to 2 plus negative 14 over 3. And then let's do that in the calculator. 2 plus negative 14 over 3 is negative 8 over 3. So x is equal to negative 8 over 3. And the intersection of these two lines, the solution to the system of equations, is negative 8 over 3, comma, negative 14 over 3. That would be where the two lines would intersect. Let's look at a more complicated example now. Let's say we have the system 2y is equal to 6x minus 4, and x plus 12 is equal to 2y minus 1, and we want to solve this by substitution. When we're solving by substitution, we want to plug in one equation into the other equation. But the problem with this question is that we don't have one of our equations solved for one variable. The question we did before, we had some equation, now we had the other equation was solved for x. In this system of equations, we don't have either equation solved for x or for y. So to solve this problem, we have to first solve one of these equations for one of the variables, and then we could plug in. So let's solve the second equation for x. To do that, we're going to subtract 12 from both sides. And then we have x is equal to 2y minus 1 minus 12 is negative 13. And now we have this equation, and we rearranged this equation to look like this. So we're going to plug in one we just solved for x into the first equation. 2y is equal to 6 times, we have something for x, we know that x is 2y minus 13, minus 4. The goal of doing substitution is to be able to rearrange your equations, one of your equations, so you could plug it into the other equation, and you'll have an equation with only one variable. Let's solve this for y. Now we only have one variable. 2y is equal to 6 times 2 is 12. 12y minus 6 times 13 is 78. Minus 4. 2y is equal to 12y. Negative 78 minus 4 is negative 82. We're going to subtract 12y and subtract 12y from both sides. Let's bring it up to the next column. 2y is equal to 12y minus 82, minus 12y and minus 12y. Negative 10y is equal to negative 82. And we're going to divide away the negative 10, divide by negative 10. Y is equal to, let's reduce this, 2 over negative 10 is 41 over 5. So that would be the y-coordinate of the intersection of these two lines. Let's solve for the x-coordinate. We know that x is equal to 2y minus 13, and we now have a value for y. So x is equal to 2 times 41 over 5 minus 13, and let's just do this whole thing on the calculator. 2 times 41 over 5 minus 13, enter, 17 over 5. So the point of intersection of these two equations, 2y is equal to 6x minus 4 and x plus 12 is equal to 2y minus 1, is 17 over 5, comma, 41 over 5. Let's look at one more example of solving systems of equations algebraically using substitution. Let's say we have a system of equations y is equal to 1 minus 6x and y is equal to 12 plus x. This is a special example, a special type of system of equations because we have both of our equations set equal to the same variable. We have 1 minus 6x is equal to y, and we have 12 plus x is equal to y. This makes it much easier to solve the system of equations because we know that y is going to be equal to y. And if y is equal to 1 minus 6x, and y is also equal to 12 plus x, then we know automatically 1 minus 6x is going to be equal to 12 plus x. And now we have an equation with just one variable, and it's very easy to solve. Plus 6x and plus 6x. 1 is equal to 12 plus 7x. Minus 12 and minus 12. 1 minus 12 is negative 11. Negative 11 is equal to 7x. Divide by 7 and divide by 7. X is equal to negative 11 over 7. That's the x-coordinate of this intersection of these two equations. And now we have to solve for the y-coordinate. To do that, we could plug in this x into either equation. We'll get the same answer. Let's use the first one. Y is equal to 1 minus 6x. So y is equal to 1 minus 6 times negative 11 over 7. And let's solve that on the calculator. Y is equal to 73 over 7. So the point at which these two equations intersect is negative 11 over 7, comma, 73 over 7.